right, hello, this is Mrs. Plisko, and this is some ionic bond review. Notice right here, I've said that if you take notes and show them to me after the break, I will give you extra credit. So I'm giving you the opportunity to make up some points. The point of this is so that you don't forget everything we did before break while you're on break. So we're just going to go over ionic bonds in a basic form. So ionic bonds are between metals and nonmetals, right? So metals we have on the left side of the periodic table, and these are all of the elements that are going to lose electrons. So they have less than 3 valence electrons, and they are going to lose them. When you lose electrons, you form positive ions, also called cations. And then we have nonmetals. These are on the right side of the periodic table. These are all of our elements that have more than 4 valence electrons, so they are going to gain electrons. Remember, we are going to gain to get to 8 electrons. And they are going to form anions, or negative ions. So just a little review with the periodic table. We have groups that go downwards. Okay, these are groups. So we have group 1, 2. Remember, we skip this middle section. We have 3, 4, 5, 6, 7, and 8. And just a little reminder that the group number tells us how many valence electrons. Okay, so if we have group 1, this is going to have 1 valence electron, everything down this group. All of these elements down here are going to have 2 valence electrons, 3, 4, 5, 6, 7 valence electrons. Something that is special about this group right here, these all have 8 valence electrons. Remember I said in class 8 is great, so these elements here are all stable. Okay, they are happy where they are. These elements here in group 8, these are not going to bond with other elements. They're going to exist on their own. For the rest of them, if we take groups 3, 2, and 1, these are our groups that are going to lose electrons. And if we look at groups 5, 6, and 7, right, these are going to gain. So let's do some examples. Okay, so just like we've been doing in class, we have K and we have F. These are 2 elements on the periodic table. So our first step here is going to be to figure out the charges. So at the periodic table, we needed to find K and we needed to find F. So if we find K, it's going to be over here in group 1. F is going to be over here in group 7. Okay, so what do we know about elements in group 1? We know that they have 1 valence electron. Yes? So then we look over at F, it's in group 7. So we know it has 7 valence electrons. So if we draw 7 electrons there. What we know is that K is going to donate its electron to F here to make F stable. Okay, so what we wanted to know was what our charges are, right? Step 1 is to figure out the charge. We know that if we lose electrons, we become positive, and when we gain electrons, we become negative. So our K is going to lose an electron, so it is going to become positive. Our F is going to gain that electron, becoming negative. In step 2, we have to figure out the products. Okay, so the products are what goes here. It's what comes out of adding these two things together. Now, K had a +1 charge, F had a -1 charge. So this shows us that we only need one of each of these to make each other happy. So our products are pretty simple. It would be K, F. If it helps you to put a 1 here, indicating that you only need one of each, that's fine. However, it's not needed. You don't have to put that there if that does not help you. Let's try another one. So we have Li and O. So we have lithium and oxygen here. Step 1 is to figure out the charges on lithium and oxygen. So if we go over to the periodic table, we can find lithium over here in group 1 and oxygen over here in group 6. This tells us that lithium has 1 valence electron and oxygen has 6 valence electrons. Okay, so we know that lithium has 1 valence electron and that oxygen has 6 valence electrons. When we fill this in, we see that lithium can donate 1 of its valence electrons to oxygen. However, oxygen needs 1 more to be happy, right? So Li, its charge is +1 because it loses 1 electron. Oxygen, however, has a charge of -2 because it needs 2 more electrons. So in order for everyone to be happy, these two numbers need to equal 0. So right now we have +1 and -2, so we still have a balance of a -1 here. So our solution would be to add 1 more Li with an electron to donate over here. I'm going to show you a little shortcut to this instead of doing it mathematically. Instead of figuring out mathematically what our charges are by counting where it's missing valence electrons. So if we go to the periodic table, we will see that lithium is in group 1. So any element in group 1 will form a cation, right? A positive ion with +1 charge. Any element in group 2 will form an ion with a +2 charge. Any element in group 3 will have a +3 charge. We're going to skip over group 4 for now because remember that one acts a little differently. We've been skipping over it. So moving on to group 5, if we look at group 5, it needs 3 more electrons. So it's going to have an overall charge of -3. Anything in group 6 would be a -2, and anything in group 7 would be a -1. Anything in group 8 has 0 charge, right? Since these don't interact with anything, they don't need to gain or lose. They are happy as they are. So if you know you have an element from group 1, its ionic charge will always be +1. Any element in group 2 will always be +2. Anything in group 3 will be +3. So even if I wanted to combine K with SE, right? No matter what, I would know that K would have a +1 charge and SE, right, would have a -2 charge. Okay. Step 2 would be to figure out the products. So this gets a little tricky when we have elements that don't have the same charge. So we have Li, remember this trick, Li has a +1 charge, oxygen, O has a -2 charge, and remember our trick where we just drew them underneath each other, and we did one of these, where we took this number and put it here, and this number and put it here. So this tells us, right, that we have Li2O1. Now remember, you don't have to include this 1 by putting nothing there. It's assumed that there is 1. So our total answer here would be Li2O, right? So we need 2 lithiums for every oxygen atom. So let's try one that's a little tricky, and this is where the shortcuts are really going to come in handy. So we have magnesium and nitrogen, Mg and N. So our charges, figuring out the charges, let's use the shortcut. Okay, so using the shortcut, we can find Mg over here in period 2 and N over here in period 5. Now remember what I said, that anything in group 1 would have a +1 charge, anything in group 2 would have a +2 charge, anything in group 3 would have a +3 charge. We are going to skip group 4. Anything in group 5 would have a -3 charge, anything in group 6 would have a -2 charge, anything in group 7 would have a -1 charge, and anything in group 8 has no charge at all. So right now I can easily look at this and say, okay, Mg has a +2 charge because it is in group 2. N has a -3 charge because it is in group 5. See how much simpler that is, rather than figuring out how many valence electrons it has and how many it needs to gain or lose to get to a happy place. So this will save you some time in the long run. So figuring out the products, right? So another shortcut. So now that we know our charges, we have Mg, which was a +2, and we have N, which was a -3. And let's use the shortcut with the crisscross. So we draw Mg and N, and we take this number and we put it down here. So we have 3 here. We take this number, we put it down there. So we're going to have a 2 here, making our final product Mg3N2. So we need 2 nitrogens and 3 magnesiums for everyone to be happy. Okay, so this one you are going to try on your own. And remember all of the tricks. If you need to go back and rewind, that is the beauty of this video. You can go back and see how I did my shortcuts for each step. What I want here is I do want to know the final product. So I want to know how many of each of these I need. And I'm also going to want you to show me what the charges are on each of these, right? So I want to know what the charges are on these. And if you bring this in to me next week when we're back, you will get some extra credit. So good luck.